Hey guys, welcome. This is our review worksheet. Let's get right into it. We got a bag of 15 marbles, 3 red, 3 blue, 3 yellow, 2 green, 4 black. So what's the probability we get 1 marble, red or green? Well, we have 3 red and we have 2 green. So or usually means add. So I'm going to add those. So I have 5 different marbles I'm trying to grab out of the total of 15. We can reduce that to 1 out of 3. Part B. Blue, yellow, or black. So we actually add those up together. So 3, 3, and 4. So we have 10 out of 15, and that gives us a 2 out of 3 probability. Johnny's flipping a coin, then he rolls a die. What's the probability he gets a tails and then a head? Well, 2. Sorry, tails is 1/2, and a 2 would be 1 out of 6 on a die. Multiply tops and bottoms, we get 1 out of 12. Probably he gets a heads, which is 1/2. Even number, there's 3 even numbers on a die of 6 total outcomes. We get 3 out of 12, and we could reduce that to 1 out of 4. Okay. Next, we're going to take a look at some cards. So we have a king. So the probability of a king, well, there's 4 kings, 1 for each suit out of 52. And we could reduce that down into 1 out of 13. A black card. Well, half the deck is black and half the deck is red, so that would be 26 out of 52, which we could just say is half. A club or a diamond. Well, there's 13 club, 13 diamonds, so that's going to be 26 out of 52, or 1/2 as well. A red queen. We have 2 red queens, a red of hearts and a red of diamonds, or sorry, queen of diamonds and queen of hearts. So that's 2 out of 52, which becomes 1 out of 26. Probability you get a black face card. Well, there's 2 black suits and there's 3 face cards each. That's going to be 3 times 2, which will give us 6 out of 52, which we can reduce that to 3 out of 26. Probability of picking 2 cards, so getting a red without replacement. Well, we have 26 out of 52 that are red times, now we're not replacing it, so I take it out. So instead of 26 red, now I only have 25 red and only 51 cards in the deck. Multiply those together and reduce would be 25 over 102. If we did the probability of getting 2 red cards with replacement, well, 26 out of 52, so that'd be 1/2 the deck is red, and we put it back, we still have half the deck being red, so we end up with 1/4. Okay. Next is permutation combination. Now, permutation combination is all about how we arrange and order things and group people. Okay, so we got to make sure we're doing arrangements, permutations, all that when we're supposed to be doing it. So in this one we have 40 people, 12 are going to lunch. We don't care the order, they're all going to lunch. So we just do 40, choose 12, and we get 5, 5, 8, 6, 8, 5, 3, 4, 8, 0. The softball team has 14 girls. We're picking 3 different positions. Since we have positions, the roles matter. So this is going to be a permutation, so 14, and we're going to pick 3 different spots, which is going to give us 2184. How many ways can 6 people line up? Keyword line up is going to be a P, lining up, order matters. So we're going to do 6P6, which is going to give us 720. Your mom told you have too many pairs of shoes. You have to donate 4 out of your 22. How many ways can we choose 4? Well, the Goodwill does not care the order in which you give them the shoes. They just want the shoes, so we're going to use C here, 22C4, which is 7,315. You're going on a camping trip. Your dad told you you're only allowed to pack 4 shirts. You have 16 shirts. How can you choose 4? Again, order doesn't matter how you pack them as long as you pack them. So 16, choose 4, and that leaves us with 1,820. You have 7 different pieces of artwork. You want to give 4 of them away to 4 different people. Because we're giving it to 4 different people, order matters. The artwork is not going to just one person. In that case, he doesn't care the order because he gets all 4. But we have 4 different pieces going to 4 different people, which means order is going to matter. What if one of those is worth $1 million? Then you would definitely want to be the one that gets the $1 million painting versus the one that gets the worthless painting. So 7, and we're going to use permutation 4. So there's 840 different outcomes for that. On the back. All right, so this one's very similar to our cards. Let's go ahead and take a look at this one. So we have a bag of M&Ms, and we're going to go ahead and select from those bag of M&Ms. What's the probability that we get a blue M&M? Well, first we have to understand which ones or how many we have. If we count them all up, we have 26, and there's 6 blue. So we're going to get 6 out of 26, and that reduces to 3 out of 13. Let's probably get a red or yellow, so we're going to add the red and the yellow together. So that's going to be 4 plus 5. So that's 9 out of 26, and that will not reduce for us, unfortunately. What's the probability to get a yellow and then a green one, and we are not, we are replacing, I apologize. So we are going to be replacing. So probability that we get yellow is 4 out of 26 times, we put it back, and we get 8 out of 26. Multiply those out and reduce, leave us with 8 out of 169. Next, D. Now we're not replacing, so the first one is pink, that's 3 out of 26 times. Now I know I'm going to be out of 25 because I didn't put the pink one back. I'm looking for a red. I still have the same number of red in the bag, which is 5. We multiply across and reduce, and we get 3 out of 130. Make sure you're multiplying that top and bottom, and then we reduce on our calculator. All right. How many 7-digit phone numbers can be created if the first digit cannot be 0? Okay, so this isn't how many ways I can order things or arrange things or choose things. This is what we call fundamental counting principle. So how many decisions do I have to make? And how many options do I have for each? So I have 7 decisions. How many options do I have for this? Well, I can't have a 0, so I have the options of 1 through 9. So that's 9 different options. Then I can use 0, so that's 10 different options for each other number in my phone. Then we just multiply all those together. And that's going to end up with 9 million different outcomes. Okay? Diana's creating a password. She wants 3 different letters and 4 different digits. So I'm still making 7 decisions again like I did last time. But I need different letters, so I can start out with 26 options for the first one, but I'm going to pick one of those letters, and I can't pick it again, so that leaves me with only 25 and then 24. Same with the numbers. I start with 10, but then I get less numbers as we go. And we're going to multiply all those together, and I believe I multiplied this correctly. It's very important that you show your work. If I see this, but this might be the wrong number, I can still give you credit because you set it up correctly. The next one says repetition is allowed. So instead of doing 26 times 25 times 24, I can actually do 26 to the 3rd power times 10 to the 4th power because it's the same number, but we can repeat. And if this is the case, we're going to have more options for us. And 1 second, I think I got something going on here real quick. Screen or my, there we go. Okay, I think. Okay, I think we're okay. All right, sorry, screen went a little buggy. We get 175,760,000. Okay. License plates can be created. The first character must be a letter, so we're going to have 26, followed by 3 digits. That's going to be 10 to the 3rd power, because there's 3 of them. It doesn't say I have to repeat any, or I'm allowed to have repetition here. And then followed by 3 letters. Okay? So I actually didn't do this one beforehand, so I'm going to have to do this one right now. And we're going to get to the third, and then times 26 to the third, and we're going to end up with a fairly large number here. And that's 456,976,000 total. All right, Sue's going out to dinner. She can choose between 5 appetizers, 6 main course, 4 drinks, 8 desserts. So 1 appetizer, that's 5 options. 1 main course, that's 6 options. 1 drink, that's 4 options. And 1 appetizer, that is 5 options again. So don't be confused. I gave you 8 desserts. That doesn't mean we actually use them. Just like when you go out to eat, that doesn't mean you're actually going to use them. We come up with 600 by multiplying. All right, now we're going back to probabilities. And we know it's a probability because it says literally what's the probability. We have 10 numbers, numbered 1 through 10. So what is our probability? So that's a 2. That's going to be 1 out of 10. It's an odd number. Well, half of the numbers are odd, so it's 1/2. Less than 4, that's going to be 3, 2, 1, and that's it. So that's 3 out of 10. Between 2 and 4, what number is between 2 and 4? It's the number 3, so we get 1 out of 10. And it's a 1 or a 3, so that's 2 numbers out of 10. So I didn't reduce that last one, we could reduce it to 1/5. Okay. And our last one, the names of 3 seniors, 4 juniors, 5 sophomores are placed in a bowl. Name is drawn at random without replacement, and then the second's drawn. First name's a junior, so first of all we got to figure out how many total kids we have here, and I believe it's 3 plus 4 plus 5, so that's going to give us a total of 12 kids. How many are juniors? 4. And then we're going to pick another kid, but we have reduced our sample space from 12 to 11, and the senior is going to be 3. Multiply those two together and reduce, we get 1/11. Both are sophomores. We start out with 5 out of 12. We reduce down to 11. And we also picked one of the sophomores out, so we reduced the 4 down. And we do 5/12 times 4/11, which gives us 5 out of 33 once we reduce. All right, now we're doing it with replacement. So in this situation, we have 20 kids. And first name's a junior, so that's going to be 6 out of 20. And we replace it, so we still have 20. And the second name is a sophomore, so that's 4 out of 20. And we're going to come up with 3 out of 50 once it's reduced. And both names are seniors. Okay, so we have 2 out of 20, put it back, and 2 out of 20. And that's going to be 1/100 reduced. All right, all of our ICs, in-class assignments, worksheets 1 through 6. This was worksheet 6. Worksheet 4 is also on the video. Those are due for the test, and we also have all the notes packet due. All right, we'll see you guys. Extra.